You're recording
Yeah.
now? So we don't touch machine management for now. Just go to the test management here. And we have a setup called Sadie Lab. I built it earlier for all that. So when you go to when you select it, test management, Sadie Lab, and here we have edit. You can add it, copy it, rename it, and here we are going to edit it. For different tests we are going to edit it. For general and control channel we don't change it, but for the specimen we can select the specimen and size of the dimension of the specimen. It can be round, you can see the round has a diameter, length, or it can be flat. When you have a rectangular shape, it can be like a pipe. You can define different dimension. But the samples that we have for now is round, right? So for a round, we have a gauge length and we have a diameter. For this, we should measure it using a caliper, but let's say,
I think
do you
it's,
remember? 30?
Yeah, it's about,
I think that's 30.
yeah.
I guess, I'm not sure. But we can measure it later, that's fine. Let's say it's 28, it's not 30, I guess. And the gauge length, this one was 11, if I remember correctly, for a D3 or what we can,
Gauge length? What's gauge length?
the length. Here,
Oh,
the length.
okay.
Because for the stress, this diameter is used to calculate the area. So here we have a load cell, right? For the machine, here we have a load cell, and using a sensor called LVDT, it measures the displacement. So we can, as we put the structure here, it compresses, it can measure the force and displacement. Force divided by the area gives us stress, and displacement divided by the initial length gives us the strain, correct?
Yeah.
So gauge length is used for strain, and diameter is used to calculate the
For the
stress.
stress, yeah.
Yeah, perfect. So we made change here. We select the type, which is the round, and length and diameter. We saved it. We should save. And you don't need to change the extensometer. I don't know what's that.
Okay.
So just from the test management in general tab, just change the specimen.
Just put the specimen. Okay.
Next, go to the segment. Like, you can select next. For now, I'm gonna remove this because to remove this. So, in the default version, it's like this.
Okay.
So select it and go for the edit.
Okay.
Correct? Pre-condition, we don't want to change it. Post-condition. Post-condition is used, I don't want to open the export for now, but post-condition, you compress it. If you select go to the home position, it goes back to the original position. But now just we are gonna do the compression, just the loading. We don't want the unloading part. So we uncheck this one. For now, just we need the channel. For a segment that we selected edit, just go to the channel section. For a channel section, you don't need to change the control setting, just here. Down ramp is used when you want to have a compression. Up ramp, I think it's used for having the tensile, it's going up. And dual is for, like, it's not changing. You can define different steps, but since we are gonna have the compression, just the compression, we need a down ramp, correct? Rate is the velocity,
Yeah.
is the rate. So you can, here you can see the machine can go from velocity 0.051 millimeter per minute to 2032 millimeter per minute.
Okay.
It's very static, right? It's not 2000 millimeter in 1 minute. It goes 2000 millimeter, 2 meter. 2 meter in 2 minutes, in 1 minute, at the max, at the max. So for now, for the static test, to have a rough estimation of, like, for static compression test, it can be from usually like 1 millimeter per minute. Like in 1 minute, it's just go 1 millimeter. But it's still too static. I'm gonna, for now, do 100 millimeter per minute, which means that in, let's say 10 millimeter, in 1 minute, it goes 10 millimeter, 1 centimeter in 1 minute, correct? So this is the rate that you specify for the machine and channel. So we have a length, like for this material was around 11, and this is the end value. If you're gonna go for 50% string, for example, the length is 11. What should be this number, do you think? If it's 10 millimeter,
Oh, it would be 5, right?
5 for
Yeah.
10 and 5.5 if for
you-
the 11.
11, yeah.
So that's the end value, right? And save it. So far, machine management, we don't change it. For a test, we go to the test management, select the Sadie lab that we define, go
We
to
edit
the edit,
the test management,
yeah.
change the specimen correctly,
Specimen,
and then go to
save
segments.
it,
Yeah,
next,
save it, and then go to
and
segments.
segment, edit, here, just channel.
Channel.
Right.
What is a segment? Is it just the test itself, like what it's gonna do when you click start?
Yeah. When you
Okay.
start, you specify the rate, how fast it's gonna compress, and to what extent it's gonna compress, right? Like 5 millimeter, 10 millimeter.
So having
Correct.
2 segments would mean that
Two
you click it
segments?
once and it does something, and then the next time you click it, it does another thing,
Uh,
and then
if
it'll
you wanna
end.
have, for example, 2 segments, let me show you how it changed. You can define 2 segments for this machine, I guess, for this setup. We define first segment as a compression to a specific point. For example, we are gonna have another segment to stay at that point, like
Okay.
compression to some strain, and keep staying there. For here, we go, for example, we define a dwell. It compress at that rate to that value of the strain and stay for 1 minute at that point.
Yeah.
This is called relaxation test. I explain later. This is the relaxation. But for now, we just want to have the compression test. So I remove this. Right? You got?
Yeah.
So save it. Next, go to the calculation safety. Here, safety is defined because the maximum load for this machine is 5,000 Newton, 5 kilonewton. I define a safety when it reached to 4,800 or positive and negative.
To
It can stop.
Yeah.
You don't need to change it. Runtime setting, I don't need to change anything. Just go for the online section. That's it. So here we have a controller. It has a fast jog and slow jog. If you press the fast jog, it's connected. It's changing. I think they changed the rate. It's very slow, I guess. The machine is not connected. Oh, there's no connection here. Yeah, you can stop it for now because. Did you stop it? You can pause it. Let's see if it's not connected yet. Yeah, I disconnected the LAN cable.
Oh, okay.
So, you're recording now? So for the online, first we should select the setup that we design, we assign. So, was Sadie Lab.
Sadie Lab, yeah.
And here you can select the specimen name. So here setup, and here you select. Let's call it test 1 D3O. And gauge length was 11, diameter 28. Okay. Now we can use the fast jog or slow jog to change the machine. Sometimes you encounter error. You should touch this. because it say it's at the limit, but it's not.
Okay.
Just change it.
Mhm.
So, put our sample here in the middle. So before touching there, before touching, see here we make everything 0. 0, 0, 0, and 0. This is the load and position. And it's just a strain. So with no force and 0 position. So we keep going with the fast, and now you can do the slow job. Now the force is 0. We want to find the point that it touched the structure, right?
But no pressure on it, right?
Yeah.
Yeah.
But we should, yeah. So we go down, down, till to a point that we see a force here goes up. You saw? So we define 0. Before touching, we define 0, correct? Now we...
So you went back up and then touched 0.
Exactly.
Okay.
Yeah, you're correct. So go down, and you see the load goes up. Now touch, and there's a load on it. I usually do this. Like I go up to have a force like 1 Newton. It's kind of preload. That's fine. You can go back to load 0 and 0 everything, or it's not a bad idea to have 1 to 2 Newton preload on it, right? So here is 1.4, 1.3. That's good. So now it touched and a little bit. 1 Newton is nothing. Now we make load and position 0. That's the starting point, correct? So for this material, we defined 5.5
For the halfway point.
compression. Just press start here. And you see it's going down. It's very, very static. And there you see the data,
Okay.
right? And this is a stress versus a strain. You see a stress versus a strain. Now it's 26 strain, 27.3, and you can see there, right? It's compressing. It reached to 0.5 probably because we defined 50% strain and stop. Correct?
Yeah.
And you see it compressed. You press OK, and you should unload the structure. You go.
Okay.
That's it. That's for the.
And then it already just gave you that?
So for extract, excuse me.
It automatically did that when you clicked, it just showed.
Yeah. I press OK, and this PDF file will show up. And for extracting data, go to probably something like Newton or Newton report.
Okay.
This is the software and this is the Newton report. Go to Newton report. Go down. These are the PDF file. Like
Yeah.
this is the one that we did. But we wanna extract the Excel file.
Okay.
Unnamed, I guess. This is the one. Yeah, this is the data that we need. If you open it. So we have time. We have load in pound, position in inch, position in millimeter, load in Newton, stress in megapascal. It divide the force divided by the area, the diameter as we defined. The strain, this one is not a correct strain. This one is the strain.
Okay.
Strain original, I don't know what's this. It's NaN. Set point, cycle, I don't use this. If I want to have stress, strain, this is a stress, correct? And this is a strain. you can plot stress strain curve,
Okay. Yeah.
right? It's in megapascal, and this one strain does it's
Yeah.
a unit less. So can you do? Let's do 1,000 millimeter per minute.
Mm-hmm.
Same strain. Can you do that?
Yeah.
Let me.
In the middle. Now it is.
You don't need to record it. Compression.
Mhm.
We did compression, and now we are gonna do the relaxation. Let's go to the edit. Here in the segments, we define. We need. This is the compression, and now we want to define relaxation. The relaxation is we add another segment
Yeah, and we
in the channel. We
dwell
define dual.
5
Now-
minutes.
Now I'm gonna do it for 2 minutes, but the
Okay.
standard is at least for 5 minutes.
Okay.
And I'm gonna show you how the. And for this one, I'm gonna decrease the.
The channel to like 10 or something.
10 is. Let's do. 1,000. 1,000 is not bad. Let's do 1,000. That's fine. So we have a compression and 2 minutes relaxation. Nothing need to be changed because the dimension, everything is similar. Go to the online and let's see. Make it 0. Zero, zero, zero. And start.
Oh, did we
Oh.
name? Yeah.
Sorry. Sadilab relaxation. Relaxation. D3O. And this is for the 50% strength. I don't know. Go to the 50% strength and relax.
Okay, now it's gonna just wait for.
So the one that I showed you is it was stress versus time. The one that I but you cannot see it here. Let me do it one more time. I stopped it. Oops. So we should give it enough time. If you want to have like standard testing, you should give them enough
And the
time
time to come back. Yeah.
to rebound. Yeah. So everything is force 0. Zero, zero. And I'm going to see the stress versus time, just the visualization. First. And we start. The stress goes up and should stabilize. Right?
Okay.
We expect, like generally,
Uh-huh.
I also expect that when it goes up, it should stay at the same stress because it is strength to a point, so the stress should be at the same time, at the same magnitude. But you see, there's a decay. I take for 2 minutes, and we use this graph for the rate dependency material development, and it's decreasing now. So you know how to do relaxation and
compression.
Compression. If I give you new samples with new dimensions and new length, you can do that, right? Yeah, that's easy. That's not. and you know how to extract the stress strain curve. You have the Excel file and you can compare it, right?